Okay. I wonder if that is pointing in the right direction. Doesn't look right. It is. Okay. So, all right, real quick here. We have a couple different things I want to cover today. You have these little pieces of graph paper in front of you. We're only going to put select problems on here today that I'd like you to do by yourself. We're not going to use all of them today. My goal is to do 2 of these. And then tomorrow we'll do 2 right when you walk in. You need to keep these, don't lose them. All right, now, first we need to get to notes. So have your normal notes out with these graphs. We're not going to put everything on the graph today. Okay, so here we go. First, we're in section 1.4. We're rapidly approaching the end of this chapter. I think there's only 7 sections because we're going to get probably homework on this stuff tomorrow. And then we'll start the next section after that. I'm looking at a test probably in the middle of next week. The reason why the middle of next week, we need to be able to have at least 1 week if you want to retake it. So I'm trying to go to the middle of next week because the week after that, we have 1 week later, so not next week, but the week after is the end of the quarter, like I said, last Friday. So we have 3 weeks left this quarter. So I want to make sure that if next week, the week after, you can at least retake if you need to, so you're not ruining your grade. Okay? All right, section 1.4, we're talking about linear functions. The goal today is to walk through a couple of these different linear functions. You've seen a lot of these in Algebra 1 and Algebra 2, but it's to go through examples of these so you know what you're doing. Okay, we did have homework. I gave you homework on Friday last week. That was page 172 in case you were gone. That's due tomorrow. I'm going to try to give you about 15 minutes a day to work. So that means I got to go quick so we can get to these 2 graphs I want to do today. Got it? All right, here we go. So first type, let's go through the types of linear functions. There's 5 types that I usually cover in this class. Number 1, first type, is point-slope form. That's the first one we're going to go to. Point-slope form. It's my go-to version. It's one of the easiest forms. We'll talk about why I would choose that one first. Second type that we're going to have, number 2, is slope-intercept. This is the go-to version for Algebra 1 and probably Algebra 2. It's the easiest one to graph, so we'll look at that one. That'll be our second problem that we'll put on the graph paper today. Third, which we're probably not going to cover today, we'll get it tomorrow. Third type is called standard form. This is the go-to version in Algebra 2. They use it for systems. When you stack 2 problems on top of each other and you solve for x and y. We did a little bit of that in geometry way back. But standard form, that's kind of a go-to method. The fourth type is one that I don't know if you've seen a lot, but we will be eventually doing this more and more and more. It's called general form. General form is really good for when you need to factor things apart or figure out x-intercepts or y-intercepts. We use general form. My stomach's growling. And number 5 is the special cases, and those are ones we're going to focus on tomorrow. Special cases. Okay. Do we understand the types?
Yeah.
Okay. Now, goal today, once we're through this, I want to do 2 examples of these problems, and these are the ones we're going to put on the graph paper so you can at least see some of these and get some practice graphing. And then if we can today, and this is be hopefully my second problem that we'll do, we're going to introduce piecewise functions today. So that's what I want to get to, and hopefully we can go there. For some reason, the other classes, like, they groaned and whined about piecewise functions. Okay, so here's, yeah, I got that from the first class. They're like, oh, piecewise. I don't know what ever happened to you in your life, but they're not that bad.
We hate that.
What is the deal? What happened? Fair enough. We'll move on. All right. So, because the first time I said that, like, oh, piecewise, I'm like, what happened in your life that you're groaning at a math problem? All right. All right. Okay. Anyway, I'll try to keep it kind of easy today. I don't know why you guys are fearing that one topic, but anyway, let's move on. Point slope. Here we go. Okay, point slope form. Now, why we have this form? Like, what's the purpose? Why would we use it? This is a form that if you're given data or data, however you want to say it, or like a graph or something, and you need to go immediately into a formula. That's why we use it. That's the whole purpose of what I would use it for. You have some data, you need a formula that can represent it. That's the go-to, okay? Now, what I want to do here today is to try to come up with a way that works for you, that makes sense for you. So here's the idea. So the form itself is written like this. We just need to, you need to see it. This is the actual formula. I need to write down the parts of what these things are so you kind of know it. This is the form. I know it doesn't look pretty, but what it stands for, M. Anyone happen to know what M stands for?
Mass.
Slope. Thank you. Slope. And then the coordinate that we have is x1, comma y1. That's just a coordinate that's on the graph that the line passes through. Because again, these are linear, right? They're straight lines. It's going to pass through. Now the other variables that don't have the little subscript ones on them, those are just variables. They're going to stay variables in the problem. They won't like change. But we're going to go to some basic numbers here. So let's draw a line here. I'm going to give you some data and then we'll try to figure out some numbers for it. So let's go with 1, comma 4. So 1, comma 4. And we're going to go with negative 2, 1. So negative 2, comma 1. And those would be my two coordinates I'm going to pick. Maybe like you're doing some experiment, you had these two coordinates, like that was your certain baseline numbers, your x numbers, what you're starting at, and then what the values will come out. And this is my line that's being represented. Okay, so you have basic information there, right? And I want to come up with a formula that represents that picture. So if you want to put this as your first graph today, that'd be an excellent thing to do. So this is one of the two graphs we're going to do today. Okay, so 1, comma 4 and negative 2, comma 1, and let's graph it. So you can put that on one of your graphs here. Yeah, I'm sorry I didn't give you any straight edges. Just be creative, use a piece of paper or something, or use your book next to you or something.
I just freehand.
Freehand draw. Okay. Now, what we're doing, we're gonna figure out the forms into this. Now, slope, if you don't know, is the rate of change. It's called an average slope, by the way. That's something that you're gonna see more and more if you go to calc for me. An average slope is basically what you did in Algebra 1. You subtract, y's, subtract x's. Why is called an average? It's over like a time period. It's not an instantaneous spot like down the road. It's not, if you had a curve, you could find an instantaneous velocity on the curve where the slope could actually change. But this is just an average. So let's find slope first. So if my coordinates are negative 2, comma 1 and 1, comma 4, how do you find slope? Walk me through it. What do you guys remember from Algebra 2 or Algebra 1?
Like, if it's as a fraction, your numerator is like how many steps up it takes to get to the next one, and then it's like the denominator is how many steps over.
Yeah.
Rise over run.
Rise over run. Best way to explain it is how far you're going up versus how far you're going across. That's what the formula for slope is. How far you're rising versus running. It's basically a right triangle, if you want to know. Okay, it's going up so many, over so many, so that you form a perfect little right triangle in there. Some people just like to count with their fingers. Oh, I'm going up and I'm going over, there's my answer. Fine, you can do that. It works every single time. Just make sure that you plug in the right spots. Now, if you don't know the formula, it's this. You subtract the y's, you subtract the x's. That's what you do. So the y numbers are the second numbers in the coordinates. So in my case, it's these two. These are the y numbers. Those are the ones you have to subtract on the top. And then the x numbers are these two. These are the x's. And you have to subtract those. Those have to go on the bottom. The number one thing people make mistakes on all the time on this first assignment, this one, that we're going to eventually get later this week, is they put the wrong numbers in the wrong spots. And they make tons of mistakes because they do it for every problem that you get every time wrong. So you have to subtract the two numbers. So 1 minus 4. So 1 minus 4. And when I do this, I just go top bottom. It doesn't matter. I don't care if I even looked at the picture. As long as you wrote down the coordinates correctly, just go top minus bottom. So I'm going 1 minus 4, negative 2 minus 1. And notice, you have to subtract whatever the numbers are. Even if they're negative, subtract the negative. I don't care. So if you're that person that looked at the picture and went, okay, 4 minus the 1 and 1 minus the negative 2, fine and dandy. You have to stick with that direction because it will give you the same math anyway. So Questions on how I set that up. Y is on the top, X is on the bottom. So this is actually gonna turn out to be -3 over -3, which is 1/1. The negatives cancel, the 3's simplified, so it's 1/1. So my slope on this problem over here is just 1. So here's what you have. You have a 1 out front. Now, in the other spots, we have to pick a coordinate. I want somebody in here to pick one of those two coordinates right here. 4, okay, 1, 4. The 1 is the X coordinate, so that's gonna go here. The 4 goes here. We picked this one. It didn't matter which one you picked, but you need to put those numbers in these locations. The coordinate you picked. So if you were the person that didn't pick 1, 4, you picked the other one, this would be your answer. X minus -2. You subtract the -2, you subtract the 1, you put them in their spots, and the slope of 1/1 had to be right there. Okay? Questions on how I set it up. I want you to somehow, some way, on your graph paper, this thing, put that problem down. So, draw it, put your slope, put your formulas, put them somewhere on that, right next to that graph, so you know how we did it. I don't care how you want to write that. That's yours. Okay, put your name on it.
Put your name on it. Leave your name.
We good so far? All right. I'll let you write that down. Next thing we're gonna do, same exact idea, but now we're gonna go to a slope intercept form problem. And so I'm gonna give you a formula and we'll go to the graph from there. But we're gonna do this for a piecewise, and don't groan on it. I'm just gonna make sure that you know how I do it, okay? All right. So we're gonna do piecewise. Okay, all right. Cam, it's not working on chemistry. Okay, we're good so far? Here we go.
Okay, we're in.
Next one.
About time.
Okay, wait, I have a question.
Okay, what class are we?
That's like just the end.
Yeah, so we have my formula, or my graph, and I wanted a formula that represents it. Now, when you have the formula, now we can use this to predict what would happen later.
So you don't need to do the
Nope, you can leave it right there. That's point slope form. Yep. So, hey, if you didn't hear Sabrina, she asked a really good question. Do we need to distribute the 1? You do not have to. You can leave it just like that. That's your formula. You can go from there. You can get to any other form as long as you know how to rearrange. So that's a really good question. Now, let's get to the second type. Second one is called point slope, or not point slope, slope intercept, sorry. Slope intercept form. All right, slope intercept form. This form is really good if you have a function, you have a formula, and you need to go immediately to a graph. That's why we have this formula. You can go immediately and start drawing the picture, so you have a visual representation of it. That's why we have it. Now the formula is one of the most famous ones. Everyone kind of knows it since you do it a lot in junior high days. MX plus B. Okay. You mean standard form?
No, I was just testing.
All right. So y equals mx plus b. Now on this formula, what does m represent?
Mass.
Oh, stop saying mass. Slope. And b.
Y-intercept.
Good. Now, what a y-intercept is, it's a spot where you hit the y-axis, and to me, it's a starting point. Now, here's the problem. If we go to a more difficult problem right now, like a piecewise function, you may never hit a y-intercept. You may never. You may not have to use it. So we just got to be careful in how you need to do this next problem. But this is usually the starting point. I like to start at that number on the y-axis, and then use my slope, rise and run from there. When I do rise and run, I always go to the right. That's just how I think of it. Some people like to go like back and to the left, or down and to the left. It doesn't really matter. I always go to the right. That's just how I think of my problem. Okay, so let's get to the second graph now. We're going to do a piecewise function on this one, and this is the second graph we need to have today. And it's the last problem today.
It's a movie.
And then we're done?
Then we're done. Last problem of the day. Okay. So, here we go. So this is a piecewise function. Alright, so here's my f of x. This is just the name of my function. They always put a curly brace out front, signifying that there's multiple parts to it. And now we're going to just do a couple things. So here we go. We're going to go negative 2x plus 1, and that's for any x that's less than or equal to negative 3. We're gonna go with x plus 5 for any x that's that is less than 1 but greater than negative 1. And I'm putting an equal sign in there. And the last one, we're gonna go with 4 minus x for any x that is greater than or equal to 6. No, yes, let's go 6. That'll work. Okay, there's my function. Now, what you're looking at here, in fact, I'm gonna put a dash line. I normally don't have this dash line in here. I'm just gonna put it so you can visually see what I'm doing here. Alright. Okay, what you have is you have a formula out front, and you have some domain in the back. So the domain is back here. In fact, let me label that. These are the domains back here. This is the domain, this is the function. Okay, I'm going to show you the easiest way that I do these things, so you never get it wrong, and it's easier than pi to do it. Okay? Alright. And in fact, I'm going to try to color code these in the 3 colors that I picked. We're going to do the top one in blue. Now, you guys don't have the luxury of doing that. I would like this problem on your second graph today. So if you have a little bit of room on your second graph, write down these 3 functions and write down the domains next to them. We're going to draw them all in one graph, one picture. Yes. All right, for the first one. Okay, this is my function. It's linear. Doesn't have any squares or cubes or any powers on it, so it is linear. This is my first number I'm going to start at. Now, it's not like I'm not finding that number like up and down. What I'm saying is that this is the first number I'm going to plug in no matter what, even if there's like a bar underneath it or not. It's saying that I can pick any x less than or equal to negative 3. That can be equal to negative 3. So I'm going to pick that number to start with. If I were to plug in negative 3 in here, what do you get? So negative 3 times negative 2, 6, and then you add 1. So 6 plus 1 is? 7. So when I plugged in negative 3, I got 7 out of that. I think the negative signs cancel. Okay, does that make sense what I just did? Yes. That's the first dot for this first one I'm going to draw. So negative 3.
Sinead Wheeler, please come to the office. Sinead Wheeler, please come to the office.
All right, there's my first dot. And notice it's filled in. The reason why it's filled in, I could be less than or equal to that one. Okay, does that make sense why I picked that number first? Now, if there was been a little bar there, I would leave it as an open circle. Whatever that number was. And again, how I found that, I just took the negative 3 that they told me, and I just plugged it in here and I figured out my answer. Now, what we have to do next is plug in another number that is clearly less than or equal to negative 3. Negative 2, good choice. So we're going to plug in negative 2 now. So negative 2, plug that in. I should say less than or equal to negative 3. So it's got to be less than negative 3. You pick negative 2, that's great. Negative 4. Negative 4. To the left. Okay. So as negative 3's here, we need to be this side of it. Negative 4. Okay. So we're picking negative 4. So negative 4 times negative 2 is what? 8? And then you're going to add 1. So 9. So we pick negative 4 and it gave us 9 out. And that again is a dot. So negative 4, comma 9. Boom. And this graph is going that way. Because I can go anywhere less than negative 3. So that's where the graph's going. It's linear. I knew I could just connect the dots with a straight line. Any 2 dots make a straight line. Again, it's third from the top. That's how I know where it's going to be. Okay, does that make sense how I did that? Yeah. So I picked numbers that are strictly less than negative 3. Okay, let's go to the second graph now. The second graph is going to be in green now. Second graph. So, this one. Now they're telling you the numbers I can pick. Just pick the outside numbers. One of these will be a closed dot. This one will be an open dot because it doesn't include it. So let's plug in negative 1 in here. Negative 1 plus 5. Negative what? 4, I mean? Not negative, but it's going to be 4, right? So, and I can be including that dot. So negative 1 comma 4. Negative 1 comma 4. And that'll be a solid dot. Now let's plug in the other number. Let's plug in the 1, the other number that they told me I could be. I could be strictly less than 1. Let's plug in 1, even though I got to be less than that. What's 1 plus 5? 6. So here's my other part, 1 comma 6. Now, that dot needs to be open. an open circle there, because I couldn't include, I had to be strictly less than 1, so I'm supposed to not include it. So, 1 comma 6, 1 comma 1, 2, 3, 4, 5, 6, and I'm gonna put an open dot there and connect them. Because I was everywhere in between -1 up to 1. Does that make sense when you're supposed to use open dots versus closed dots? And they have the bar when they don't. And I always use the numbers that they recommended. So the numbers that they printed, even though if I can use it or not. I just make sure it's open circle versus closed. Question?
Are piecewise functions ones where you have to like sometimes do like a dash line or something like that?
That's when we're doing systems and whatnot. Like when you're trying to like look above the graph. That's inequality signs, greater than or less than signs. Yeah. Piecewise or any time you're just drawing multiple pictures in one graph. That's all it is. So as you can see, I already have 2 different things from. Okay, last one. Last one here. What number should I start with? 6. So let's get rid of these. I'm going to plug in 6 now, and you're going to plug it in here. 4 minus 6. -2. So there's the first step there. So 6, 1, 2, 3, 4, 5, 6, -2. And that is a closed circle. That's a closed dot. The reason why it's closed is because I can include it. I could be greater than or equal to 6. And what's another number that's greater than 6? 7 or 8. I don't really care which number you pick. Let's pick 7. 4 minus 7, -3. So -3. So, and that graph's going that way. So if you pick 8, it'd been -3 or something like that. -4 maybe. All right. So there's your graph. There's 3 distinct graphs, and why I know there's going to be 3 is because there's 3 individual functions. There's no overlapping at all on these. Doesn't look like. The big thing I want you to know is you're just drawing 3 pictures. They tell you which number you start with, and you just plug in other numbers that are either greater than or less than. The part that I want just make sure, because I almost made a mistake myself. When you pick numbers that are less than, make sure you're going to the left. And if you pick greater, you're going to the right. That type of thing. You just see where the arrow's going. Some of them don't have arrows, like that middle, you're in between numbers, so they tell me what numbers to pick. Is that as bad as it was a long time ago? Alright. No. Alright. Okay, we good though?
Yeah.
Okay, we're done for the day. You have the rest of the time today, that's about 15 minutes or so. Let's work on your page 172, it's on the spot on 15. I have this down to a science today.
That was a good day of pre-calc.
Come on, brother. Dave?
Hey, you need to keep the graph paper. We are going to graph on that tomorrow, and you will turn it in. Yes, well, yeah. No. Appreciate the question, but no.